Okie dokie. I have the fluke on the Asteroids board. It is turned on. Fluke is turned on. I've already done the setup. And if I do a bus tester auto, it gives me this. Control error bit 4. See, bit 0, 1, 2, 3, 4. So we have a control error bit 4. Now what we have to do is consult the Fluke pod manual, the 6502 pod manual, and if we come over to, what you doing? We come over to the Fluke pod manual. What are you doing? Hanging out in front of the TV? Boo boo. Hey boo boo. Yeah. Wah. Okay, anyway, control lines, bit 4, remember? Bit number 4. Read write. Remember, we were not getting anything on the read write. It's undrivable. Something connected to that is making it undrivable. Read write off of the CPU. So we come back over here. And I did go ahead, before I was going to hook this fluke up, I replaced the sockets. I replaced these guys, that guy, and the CPU socket. Just to get that out of the way. So, we have a problem with the read-write signal. So I'm going to go over the schematic in the decoding area, and I'm going to look at everything that's connected to read-write. I know this 244 is, and this 244 could be holding that signal high and shorten it high and not allowing it to drive. So we'll have to see. I'm going to try to hunt down that signal everywhere it's at and go from there. Okay, actually, we're going to do this together. So where's my coffee? No, I'll be right back. So, I'm going to, and I'm still looping this. I'm looping that control error issue. No, I'm not. I am going to loop it. Now it's looping. I'm going to pull this schematic out, and we're going to look at RW, the signal, the schematic. And right here it is off of the CPU, RW, okay? And yeah, R / not WB means buffered. And I don't see where it goes anywhere unbuffered. I'm just going to continue to look around. That's my question, is does it go anywhere unbuffered? Just RW, is that used anywhere? I really don't think so. I think the only, it's going to be used in like this 245 buffered. I think our culprit I really think the culprit is going to be B2, 244. So it goes in, it looks like it goes in on pin 2, but I don't think it does. You know what I want to do? Remember how it was weird, how it was like, okay, it's pin 16 that... I don't know what's going on here with this. You know. I want to remove this 244. I want to remove this guy. I really think it's funky. I'm looping that right now. One, two, three, four, five. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Guys, I'm trying to clear this control error. I don't see what else is connected to RW except for this 244. Pin 4. Try pin 4. That's still doing the same damn thing. I don't know. Uh-oh. Is this a problem with my cable? Now it says it's okay. I got a bad cable, damn it. Now it's cleared. Son of a bitch. Okay. This is just a funky cable, I think. Not heavy duty. I think I'm going to have to maybe buy a pod, a cheap pod on eBay just for the cable. That's unacceptable. Well, I need to replace. Okay. Son of a gun. I'm going to turn this off. I'm going to turn the fluke off. I don't know. You know, fluke tests okay now. Okay, darn it. Well, I ain't digging that. I'm gonna have to get a proper fluke cable for this. It's a must. Kind of renders the fluke 6502 pod useless if I can't use it. Confidence that the cable's good. So I will be looking for a pod with the good kind of cable that's just cheap. You know, a pod that nobody wants, you know. Buy it for the cable. Preferably one that says it's tested working or whatever, you know. But now I have to go ahead. I have to replace this guy. Irritating. I'm gonna let this heat up. I will come back. I'm not gonna sit here and film replacing this chip. So I'll be back. Okay, as you can see, I have scammed the cable from my 8085 pod for the time being, since it's the pod I use least. And it's a short cable. It doesn't even reach up to here, but it works. So for now, good enough. And I'm just running a ground. I'm just grounding that wire right there. I'm just running that to the ground lug to ground that cable. But I got it on there, and it's giving me a decoding error. If I try to do a RAM 0 to 3FF. 0 to 3FF. Yes, that is RAM, I believe, on an Asteroids. And go ahead and do it. It will kick back a decoding error. So we have a decoding error. And I did replace this guy. Okay, address decoding error. So we'll have to look at decoding. And I think the first thing I want to do is make sure, you know, it's saying bit 1. It's saying bit 1 of the address decoding is not good. So let's look into that. Okay, address bit 1. 8 out to 12. And if we look at 8 out to 12, here's 8. And I'm looping a read at RAM location 0. So it's going low. And if we look at 8 or 12, 11, 12. You see 12 is always low. Okay. Now this is RAM location 0. Let's see what address bit 1 does if we want it to go high. So let's do a read at 2. Address bit 1. So let's go read at address bit 0002. 2 in binary is 10. So that should be high, right? Okay. Loop. Now address bit 8 should be high. Okay. High. And let's see what 12 is doing. Is it staying low? Well, look at that. There's 12. That is address bit 1. It's always low. Stuck low. Undrivable. So I've replaced this guy. Now I got to replace this guy. Let's do it. Okay, so I'm not really even sure where I left off, to be honest. I was having an issue with address bit 1 being tied to ground. And I went through and I clipped everything tied to address bit 1. And this wasn't even, these weren't even tied to address bit 1. But any pin that was tied to it, I clipped, and it still was grounded. Turned out it was this socket. This socket was shorted to pin 18 on the other side, which is grounded. So it was a little flaky or something. I removed the socket, cleaned it up, put it back together, and it is working. Well, we'll have to test the sounds and see if all the sounds are there. Oh, and the CPU. Dead CPU. So I had to put a 6502 in it. Yeah. So I will go ahead and test out some sounds and do some playing and see how it goes. Alrighty, so I have it over here on the vector monitor. It's looking good. Yeah, so we'll go ahead and test out the sounds and see how it's going. Okay, I'm going to play a game, and you'll see there is one sound that is messed up. And I will show you that. A coin will start. You have to... Sounds not that loud with my AR. The Atari used a different circuitry in their AR1 for this game. So it's a little bit louder on another AR, on the actual AR. There's your bad sound, that saucer fire. The enemy ship fire is the bad sound. I'll just wait for the ship to come out. But we got the, the warbling ship sound is good, which is nice. It's just that one sound. Everything else is good. So we'll look at the schematic for the ship, the saucer fire sound, and we'll figure that out. That shouldn't be no big deal. Alright, well that's going to do it, guys, for now. So we'll look at the schematic and we'll figure out that, that ship saucer fire sound, and we'll fix that, and then we'll be ready to button this one up. Alrighty, let's get the sound schematic. Audio outputs. This one says audio outputs. That is not what I'm looking for, though. Inputs, outputs. This is the one I believe I need. Pretty janky. It's like a half schematic. We're looking for saucer fire. Saucer fire, right here. Well, LM324 at L8. That's probably it. LM324 L8. You know, let me see that again. Ship fire, saucer fire enable. Q1. Saucer fire enable is pin 5. I'm going to check out the saucer fire enable signal. This schematic says saucer fire enable is pin 5 of M10. And it's got to be M11. M10 is not the right chip. M11. This schematic does not match this board. I need to kind of probe this. You know what I need to do? I need to make sure that that is actually the right signal. So I'm going to actually probe that signal, that pin. Yeah. Now I'm going to play a game, and I'm going to probe that signal. When that ship comes out and starts firing, I'm going to see if that goes high. That'll tell me if that's the signal. Because what I want to do is, what I'm thinking is I want to jump that LM324 and then just, you know, put this signal high. That'll make the fire sound happen. That way I don't have to sit here and play it. I can just pull that signal high and it'll make the fire sound. But I need to make sure that that is the fire enable signal. So, and this schematic just doesn't match. So I'm just going to play the game and watch when that ship comes out and starts shooting. That should go high every time it shoots. That is it. See now, if I take this and I put this to 5 volts, and I just, see, I can make that. See, I'm making the shoot sound. It's really low. It's just not very loud. I got it cranked as loud as I can get it. But this AR is a later AR, and the circuitry has to be different for Asteroids, because I've actually verified that when I have an Asteroids board hooked up to my AR, it's really low sound. It's a really low sound, but if this is in an actual Asteroids board with an Asteroids AR, it's normal loud sound. It's weird. See, that's a ship fire, saucer fire. I just want to die. When I want to die, it's hard to. Okay. See, now I can just make that fire sound happen. See? So if I want to just jump that LM324 and then do that and see if the fire sounds normal. That's the plan, Stan. So let's find an LM324. And let's find an LM324 on the board. Here's one. I don't know if it's this one or... Let's just try this one first. LM324. .4066. 406. Here's another 324. Let's try this guy. Still not right. So let's look at the schematic. What else is involved? Well, there's a timer involved, a timer IC, some transistors, 4016. That could be it. Analog switch. Let's try jumping a 4016 and doing it. See if we get any kind of an improvement. We'll find that bad part. We will find it. This is a very scientific way of doing it. Jumping stuff. Okay, let's go with this guy. Dang it. Okay, and there's a 406, 4016 up here. Nope. Okay. Well, there's a 555 involved. There's actually two 555s. Saucer fire, saucer ship fire. let's try 555. And of course there are caps everywhere. Nothing seems to work, guys. Oh, darn it. I keep hitting reset. Okay. That ain't working. That ain't working. Ooh. Could just be it could be just caps. Absolutely could just be a cap. Because it kind of sounds like the right sound, almost like that, except it doesn't have the tail. The it doesn't have the tail off, and that's where the caps come in. So it could just be a bad cap. I was thinking that we might find something cool and be able to do that, but it doesn't seem like it's it does not at this point in time look like a digital failure. It looks like an analog failure. Looks like a cap. It's probably a cap. So I think good practice. I'm just going to go ahead and recap this board. That's what we're going to do. And that, I'm kind of thinking that might fix our problem. So off you go. That's kind of cool though, to see how you pull that one signal high and it'll make the shoot sound and all that. You can go through all of the sounds without playing the game. You can just trigger them, trigger all the sounds. We shall cap this board. That's good practice anyway. That's kind of standard practice with these. I have also seen bad power caps right here. If these two guys are funky, you'll get weirdness with these two guys. I've seen it. Could have a shorted out tantalum cap, who knows? We very well could. You know what I think I'm going to do? And this could just begin to be new standard practice with these boards, is I might replace the regulators just because. I've never really been one for replacing good parts. No, I'm not going to do that. Those regulators could last 20 more years. And a lot of times, I believe that they just don't make stuff like they used to. So these might be better than what they produce today. You know, that might just be me. I might be crazy to think that, but yeah, I'm going to leave that. Leave it be. Alright, what we need to do is get a pad of paper. Okay. I got a pad of paper. Kind of need to straighten up around here a little bit. Zero 04. Okay, put this stuff up. Where in the world did my pen go? I'll be right back. All right. Got my pen. What I need to do is make a cap list. These are 472. These little guys are God, I keep going. Ones. So I need 1, 2, 3, 4. Five. 1 UF times 5 of them. This guy right here is a can't tell. 22. Just one of them. So 1, 2, 3, 4, 5. This guy is 100. Okay. So that takes care of all of that. And then we got all these tantalums. We have 10 microfarad tantalums and 1 microfarad tantalums. So the 10s I need 1, 2, 3, 4. 4. And the 1s I need 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. 6. Okay. So I can pick a cap kit. Come over here and pick out a cap kit. Like grabbing an empty one of these guys, and we'll start picking a cap kit. I know I need 2 470s. These are 50 volt caps. I need a 100. I need 5 1s. Okay. I actually need 6 tantalums. And there's 6 tantalums. And I need 5 regular. 1, 2, 3, 4, 5. All right. Okay, I got the 100. I need a 22. Okay. 10 microfarad tantalums. I think it was 4. Dang it. Gotta put the camera down. Can't do this with the camera. Okay. And put that back up. 10 micros. I think that's it. There's my cap kit. Put you back up. Alright, I gotta get my desoldering gun out. Let's make sure I got all of the caps. I got those, I got that. Yep, I got them all. And I'm going to give this a good 5 minutes to heat up, and I'll be back. I'm not going to let you sit through that. I'll be right back when that's hot. Alright guys, we're going to do a cap kit. We're going to do a cap kit. Cap kit on the board. So, let's do it. Let's do it. Boom, 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 boom. What is that? Oh, it's another cap. Ooh, that cap fell right out the board. She fell right out the board. Those guys are gone. How are these looking? How do they look? That one might be a little leaky. Ooh, ooh, boy, that ain't good. It's a little leaky. I think I would like to test those caps. Maybe test out the old ones. What do you think? Where are you going? Where do you think you're going? That looks like a capacitor, and it is. It's a tantalum. That's kind of strange. Okay. Here's another cap. I can just tell. You can tell a lot of the caps on the back of the board how they look. There's another cap around here someplace. Whoa! Hey-oh. Damn. That was that guy. Yeah, this other one's right here. Cap fell right out the board. Okay. Alright. Capacitors. Now we got all these tantalum caps. Get out the board. Get out of here. And like I said, you can just kind of hunt them down and you can find them. They're, Maybe. It's so obvious when you see them. There's one. Tantalum cup. Is that one? Yep. I'm going to measure these caps and see if any of them are actually terrible. There's another. Okay. Is that a big one? I'll leave this guy here and on just in case. Just in case I need to clear out something a little bit. You know what? Let's turn that off. I want the meter because I want to look at these caps a little bit. Okay. I want to check these caps out just a touch. I'll give you a good view of the meter. And let's look at these capacitors. Let's start with the big guys. These are the 470 microfarad power caps. Okay. Not terrible. I mean, they're not terrible. That one's not terrible. Okay. And once again, you know, that's not alarming. This is a 100 microfarad cap that was across the power. Okay, that looks good. And these black caps, these 1 microfarad black caps, I would expect them to be fine, because these are high quality caps that they use. These are 105 degree caps. So I'm going to measure one of them and then move on. Yeah, these are going to be fine. Let's look at the tantalums. The tantalums are what I'm really curious about. Let's do all of the 1 microfarad tantalums first. Good. Okay, next. That is 1,000 nanofarads is 1 microfarad. So that's basically like 0.9 microfarad. So it's not really alarming. And moving on. Okay. 1.3, that's good. I want to do this one again. I want to just look at it one more time. Yeah. Okay, moving on. That one that was low, because these tantalums are pretty, the tolerance on these things are pretty good. They're usually right there. So that one that's a little off, kind of, and this one too. It's not really alarming though. That's close enough to 1 microfarad. But just because they test good like this doesn't mean that they're good under a load. But sometimes you find these and they're absolutely just garbage. Shorted or something like that. This is a 10, which looks okay. All right, next. Good. Couldn't get on that one. And 10. No. Ho hum. Nothing crazy about the caps. So we'll replace them with new caps. And replace the old and end with the new. We didn't have no obviously just junk, absolutely junk caps. But you never know. I've seen weirder things happen where they look like they're okay and then you put them, when they're in the board, they're just no good. It's weird. These. Heat that baby up. Cutters. this is 22. It's a bipolar cap. I don't want to use that. Alright, and I need my needle nose pliers. Needle nose pliers. Bending legs. Now I got all of these onesies. What do you guys think? You think this is going to fix that sound? I know what I think. I would love to hear what you guys think. If you think that capping this will fix it or not. I have my opinion. This would be cool for a live thing, just, you know, kind of doing a live stream or whatever. Kind of talk about this kind of stuff. It'd be kind of cool, I think. I should end this video on that question. Do you guys think this will fix the sound? Post this. Do some comments. Let you guys chime in on what you think. And I will keep my opinion to myself. I already know what I think. I think that's what I'm going to do. Let's cap this thing. I'll get the cap kit done, and then I'm going to end this video. Post it. Let you guys, you know, brew on it for a minute, for a little bit. Of course, I will have moved forward with the repair, but I already have my opinion on what I think about it. Okay. Those guys are done. double checking my polarities. This guy is the big cap that goes right there. Oops. Nice. All right. We're down to tantalums. Tantalum. I'm just going to cut these guys out of here. One microfarad tantalums, tight bend, microfarad, uno microfarad. Here comes the furnace. The furnace monster. Microfarad. Two more of these guys. Two more of the 1 microfarad. One's right here. And right here. And these guys, the 10 microfarad tantalums. Microfarad. Like we weren't even here. Clean. Wonderful. You'd never know by looking at the back of this that it was worked on. That's how it should be. That's how it should be. That's the goal, anyway. Alright guys, let me give you a little overview of the PCB, and I'm going to end this video. You guys comment down below you think this is going to take care of our sound woe with the you know, the little weird saucer fire sound. Newly capped. And if we look at the back side of the board, you just can't tell. You cannot tell this was capped. And holy Toledo, the battery's gonna die. So yeah, that's what I get for letting it go for an hour or so without being plugged in. So I'm going to end this one here. I'm going to plug this thing in and upload this file. And you guys comment. What do you think? You think it's going to, that sound, that saucer fire sound, you think it's going to be fixed after a recap? Let me know.